Now, conservation of mechanical energy. Mechanical energy is the sum of potential and kinetic energies for an isolated system must be constant, which means that if you calculate the mechanical energy EM at any two random chosen times, the answer should be always E mechanical 2 equals E mechanical 1. So we can declare that within an isolated system, energy may be transferred from one object to another or transferred from one form to another, but it cannot be increased or decreased. And that is the law of conservation of energy. Now, in an isolated system, what is the relation between kinetic and potential energy? We know that the law of conservation of energy is having fundamental principles, and it is a powerful mathematical model for the analysis and prediction of behavior of the objects within that system. So if you take another perspective, the conservation of energy states that in terms of mechanical energy, any gain in kinetic energy must be accompanied by an equal loss in potential energy, which means in mathematics delta EK equals minus delta EP. Now statements 1 and 2 are equivalent. This can be verified using the following procedure. Assume the total energy is constant regardless of time or position, then we can say E mechanical 2 equals E mechanical 1, but the mechanical energy is the sum of the kinetic and potential energy. So it means EK2 plus EP2 equals EK1 plus EP1, which means EK2 minus EK1 equals minus EP2 plus EP1. Delta EK, which is EK2 minus EK1, equals minus the EP2 minus EP1. So the gain in kinetic energy is a loss in potential energy, and so on. Let's take an example on conservation of mechanical energy. We have a frictionless roller coaster car that has a mass of 8 by 10 to the power of 2 kilograms. At some point on the journey, the car's speed was 4 meters per second and it is 35 meters above the ground. Later, the speed is measured to be 20 meters per second. That's another speed. Find the total initial energy, mechanical energy relative to the ground. We have the mass, velocity 1, velocity 2, height 1, and G. Find mechanical energy at 1, which is E mechanical 1. We can say that E mechanical 1 equals EK1 plus EP1, which means kinetic energy 1 plus potential energy 1. Which means EK1 can be 1 over 2 mass by V1 squared plus mgh1. Replace the values because all are given in the question, so that will give you 2.81 by 10 to the power of 5 joules. For the second half of the example, the system is defined as isolated. In this case, he's saying what is the gravitational potential energy in the second instance. So the system is isolated, the energy is conserved. So the law of conservation of energy would help us here. We find the mechanical energy at any 2 points and they should be equal. Now the gravitational potential energy at the second point should equal the mechanical potential energy minus the kinetic energy at the second point. So if we say EM2 equals EM1, EK2 plus EP2 equals EM1, so we just broke down the EM2 in this case. We can say EP2, which we need in the second half of the question, would equal EM1 minus EK2. And we have EM1 already, 2.8 by 10 to the power of 5 minus 1 over 2 mass by velocity 2 squared. We have all these variables as given. The EP2 or potential energy 2 would be 1.21 by 10 to the power of 5 joules.